Hello, everyone, and welcome to Factoring and Applications Lesson 3. Today we are looking at factoring trinomials in the form ax squared plus bx plus c. So you have seen factoring in the form of x squared plus 5x plus 6. That's a review of grade 10. But you haven't dealt with anything where there's a coefficient in front of the x squared term. So now we're going to start looking at what happens if there's a coefficient there. How do you deal with that? So we are going to skip over a bunch of stuff in this unit. I'm just kind of picking out the most important bits, and we're going to move from there. So don't freak out if we're skipping a lot. So I just want to start by looking at the first question here and looking at binomial products. So what happens when we multiply two binomials together? You know that we are using FOIL when we do that. So if we're foiling this, we are going to start by multiplying the first terms together. 2x multiplied by 2x gets us 6x squared. And then the outside terms, 2x multiplied by 4 gives us 8x. And 1 multiplied by 3x is, I'm going to zoom in just so I can, there we go, plus 3x, there we go. And then finally 1 multiplied by 4 gives us 4. So if we combine our like terms together, we get 6x squared plus 11x plus 4. And so now we know that the trinomial 6x squared plus 11x plus 4 will end up having the factors 2x plus 1 and 3x plus 4. They're just showing you that it still breaks down to two factors, but you can see that there are constants in front of our x. We are so used to factoring, for example, this guy right here, we're used to factoring it into two factors where we have x plus 2 and x plus 3. But now when we have our constant out front of the x squared term, we're going to end up getting one or even two constants in front of those x terms. I'm not going to do the next one. I just wanted to show you that we're going to skip algebra tiles. It's, I think it's more confusing than anything. We're going to review a little bit of factoring by grouping. This is kind of the second step of decomposition. So I just want to review it really quick. So I'll do one example here where we have this polynomial with 4 terms, and we can group that. So factoring by grouping is we're going to group the first 2 terms and the second 2 terms, and we're going to just pull out a common factor or the greatest common factor out of the first 2 terms there. So we can remove 3x, and we're left with x plus 1. And then we can remove out of the second one a 4, so a positive 4, and we get 2x plus 1. And I made a mistake here on the first one. If I factor out a 3x, I end up getting 2x plus 1. So now you can see that this binomial and this binomial match, and what we're left with is those two. So if I factor out a 2x plus 1, and if I factor that 2x plus 1 out of both terms, term 1 and term 2, I'm left with 3x plus 4. So that's factoring by grouping. And we are going to use that when we look at decomposition. So this is the big one for today, decomp. This used to be in the grade 10 curriculum. They moved it to the grade 11. It's a bit of a process, but it's the same process every time. So if once it clicks, it shouldn't be too bad. We'll just make sure that it clicks for everybody. So I'm going to skip over all the wordy stuff here. I think it's better just for us to go right into an example. So when we have a trinomial like this one right here, an A, where we have that constant in front of that x squared term, the first thing I want you to do is see if you can factor it out. A lot of times you can actually factor that right out if you can pull it out of every term in here, and then you just create a trinomial with no constant in the front, and that's a lot easier to factor. In this case, we can't factor that 2 out. So what we're going to do is we are going to do the same idea we did with trinomials with no constant, where we had two numbers that multiply to this and two numbers that add to a different number. But in this case, what we want to do is we're going to take the first one, we're going to take 2, we're going to multiply by the last one. So 2 times 6 is 12. And now we're looking for two numbers that multiply to 12 and add to 7. So we're looking for two numbers that multiply to 12 and add to 7. Try to write that a little nicer. So again, I'm going to make my multiplication chart. So 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Perfect. 3 times 4 is 12, and 3 plus 4 is 7. So what we do now with those two numbers is we are going to split this 7x. So I'm going to rewrite this trinomial. 2x squared. Now I split that 7x into 4x plus 3x, and then I bring that 6. So the first and the last term stay the same. I split that 7x into 4x plus 3x. And now we have a great polynomial with 4 terms, and we can factor it by grouping. So I can group the first two terms together and the second two terms together. Before we go any further, I could have put the 4x and the 3x in any order that I wanted. I could have put the 3x first and then the 4x, but I noticed that the 4 matched really well with the 2 and the 3 matched well with the 6 for factoring. So I put the 4 first. So now I can factor out the first set of brackets here. So I can pull a 2x out of there, and I'm left with x plus 2. And then in the second set of brackets, I can factor out a positive 3, and I'm left with x plus 2. And if we've done it right, those binomials match, and they do. So now that will be one of our factors, x plus 2, and the second one will be what's left, 2x plus 3. And those are our two factors. And if you wanted to double check, what you could do is FOIL that back out, and it should FOIL out to our original trinomial. Let's try that again. So we're going to first we're going to check, can I factor a 5 out of here? No, I can't. So what I'm going to do is take this 5, multiply it by the last number, and I get 10. So I'm looking for two numbers that multiply to 10 and add to positive 7, because that is the middle term there. So multiply to 10, add to 7. So 1 times 10 is 10, 2 times 5 is 10, and 2 plus 5 is 7. So that's perfect. So I'm going to rewrite my trinomial, 5x squared, and I can split my 7x into plus 5x plus 2x plus 2. Now I can group those. Oh wait, I wanted to erase too many things. There we go. Group the first one, group the second one, pull a greatest common factor out of the first set of brackets. I can pull 5x out, and I'm left with x plus 1. And in the second set of brackets, I can pull a positive 2 out, and I'm left with x plus 1. I can factor out an x plus 1 out of both of those terms, and I'm left with 5x plus 2. Perfect. let's try a couple more examples. Let's try this one in the middle here. 3n squared minus 2n minus 8. Can I factor that 3 out? No, I can't. So what I'm going to do is multiply the 3 by the negative 8, and I get negative 24. So I'm looking for two numbers that multiply to negative 24 and add to negative 2. So 1 and negative 24, I've got, or negative 1 and 24, 2 and negative 12, negative 2 and 12, 3 and 8, negative 3 and negative 8, 3 and positive 8, 4 and negative 6, negative 4 and 6. And it looks like out of all of those, 4 plus negative 6 gets me negative 2. So I can rewrite this. The 6 goes well with the 3, and the 4 goes well with the 8. So I'll put the 6 first. I'll say 3n squared minus 6n plus 4n minus 8. Now I can group. And I can pull out of the first brackets the greatest common factor, which is 3n, and I'm left with n minus 2. And in the second bracket, I can pull out a positive 4, and I'm left with n minus 2. I know I'm on the right track because my binomials match, so I can factor that out, n minus 2, and I'm left with 3n plus 4. If you want to double check, you can FOIL it all and see if it works out. All right, the next one is 15 minus 7y minus 2y squared. So they've changed the order of everything. You can flip it around if you'd like, or you can just solve it like this. So we're going to take the first. So actually check for if you can factor that 2 out, because that's the one that's causing issues. If we could factor that 2 out of everything, then we would have no problems, but we can't. So we're going to take negative 2, multiply it by 15, and we get negative 30. So now we're looking for two numbers that multiply to negative 30 and add to negative 7. That comes from that middle term there. So 1, negative 30, negative 1, 30, 2, negative 15, negative 2, 15, 3, negative 10, negative 3, 10. I'm going to stop right there because 3 plus negative 10 gets us negative 7. So I can split that up. I have 15 minus 10y plus 3. Ooh, maybe I should do it the other way. Actually, you know what? It doesn't even matter. The 3 probably goes better with the 15, and the 10 probably goes better with the 2, but if you get them backwards, that will work anyways. 2y squared. So now we can group. And we can factor out of the first bracket, we can pull a 5 out, and we're left with 3 minus 2y. And out of the second bracket, we can factor a plus y out, and we're left with 3 minus 2y. So our binomials match, which is fantastic. So we can factor that out. 3 minus 2y is one factor, and what we're left with is 5 plus y. Those are our two factors. That's decomposition. Like I said, it's a bit of a process, but it's the same process every time with different numbers. So once you know, then you're going to be good to go. I want to look at one more type of factoring. It's actually the same thing. We are doing decomposition to this, but you can see here that we have x squared and x, which is normal, but now we also have y and y squared on the back end. So we can still use decomposition on this. So I'm going to say 2 multiplied by 2 gets me positive 4. And I need two numbers that multiply to positive 4 and add to negative 5. So I have, well, 1 and 4, negative 1 and negative 4. And there we go right there. Negative 1 plus negative 4 is negative 5. So in this case, it's not going to be negative 1x, negative 4x, or negative 1y, negative 4y. We're going to split this, so 2x squared. Now we're splitting this one into negative xy, negative 1xy if you want, minus 4xy. It's important that you have both variables there. And then we're going to add that plus 2y squared on. So again, just like any other decomposition, we are going to group and we are going to factor. So in the first one, I can pull out a 2x and I'm left with x minus y. Oh, I can't pull out a 2x. I can only pull out an x. It's like, that doesn't make sense. X, we can pull out an x. There's not a 2 in the second one. So I can pull out an x and I've got x minus, I've got 2x minus y. Sorry, had a bit of a moment there. In the second one, I'm going to pull out negative 2y, and I'm left with, well, if I pull the negative out of, or if I factored negative 2 out of negative 4, I get positive 2x, and then I pull a negative 2 or factor a negative 2 out of positive 2, I'm going to get a negative y. And you can see that the binomials match. So now I have x, 2x minus y, which is what I factored out. And what I'm left with is x minus 2y. So the only difference between the questions we're doing right now and the questions we just did is that in the second term of our factors, we have the y terms because we need y times y to make y squared up here. You can see if we scroll back up, most of the time if we had a constant, well, if we have a constant in the third term, then these two numbers down here are going to both be constants, right? We had a constant in the third term here, so we had constants there. So let's scroll down. We can do one more example. I think we've got time. So you can see here, we can't factor that 2 out, so I'm going to go 2 multiplied by negative 35, which means it's negative 70. And I'm trying to find two numbers that multiply to negative 70 and add to negative 3. So you know they're not going to be numbers like 1 and 70 because we're trying to make them add to negative 3. So they're going to be a little bit closer together. So you can try negative 7, positive 10, or 7, negative 10, and it looks like that's the one right there. So we're going to split this negative 3 nm into positive 7 nm minus 10 nm, and then we have 2n squared. That's a plus now because our 7 is positive, minus 35. Hang on, let me see if I can do this thing where I go. Oh, so smart. minus 35m squared. Again, now we're going to group the first ones together, group the second ones. I probably should have done this opposite, but that's okay. Should still work. So in the first one, I can't factor out any constant, but I can factor out an n, and I'm left with 2n plus 7m. And in the second one, I'm going to factor out a negative 5 by the looks of it, and an m. So negative 5m. And what I'm left with is 2n. 35, negative 35 divided by negative 5 is positive 7. And we have an m there still. And it worked out because my binomials match, which is great. So I can factor that out of both of those. 2n plus 7m multiplied by n minus 5m. And that's our answer. So that's decomp. That's actually a big, one of the bigger or more key sections of this whole course. So make sure you know how to do decomp really well. We're going to do a lot of practice. Thanks for watching, and don't forget to like and subscribe.